Given a poset P with a partial order, its opposite is defined as the set, which will denote P superscript op, and the partial order less than or equal to subscript opt. This underlying set of P opt is the same as the underlying set of P, but what we have is X is less than or equal to Y in op if and only if Y is less than or equal to X in P. Okay, some posets are the same as their opposites. A poset is called self-dual if P is isomorphic to its opposite. So for example, you have the poset of the power set of a set 2 to the power x, where x is any set, not necessarily finite. This is isomorphic to its opposite. To find such an isomorphism, you just need to think of what it is on subsets that reverses inclusion, and obviously the answer is complement. So a subset S goes to X minus S, the complement of S in X. But of course, not all posets are self-dual. For example, the poset of non-negative integers under the usual partial order, and the poset of positive integers under the divisibility partial order, and maybe one of the examples that we had considered earlier, this poset with 3 elements. These are not self-dual. Another self-dual poset is an interval n. So this is just the integers 1 to n under the usual order. This is self-dual. And the anti-chains of self-dual. So this is a chain, this is an anti-chain. So the identity map is an isomorphism of the anti-chain onto itself. Okay, the reason I introduced this notion of opposite is to try to understand the Mobius function of the opposite of a poset. So let's first look at the incidence algebra of the opposite of a poset. So remember that the incidence algebra of a poset, AP, consists of functions f p cross p to c, such that if f of x comma y is not equal to 0, then x is less than or equal to y. And so if we are looking for functions on AP op, then this is equal to functions from p op cross p op to p, but that's the same as the set P. And f of x y not equal to 0 implies that x is less than or equal to y in the opposite partial order, which means y is less than or equal to x. So this gives us an idea that we can try to relate the incidence algebra of P with the incidence algebra of P op by just flipping the two variables. So define. This is going to be a linear isomorphism, obviously. I'll denote it by f goes to f star. And this is, so maybe firstly, it's a linear isomorphism from AP to AP op. And I'll denote it by star, and it's given by f star of xy is f of yx. Okay, so clearly this is a linear isomorphism, because this condition of which values are allowed to be non-zero is simply reversed under opposition, and so we are reversing the two variables. And now let's do a small computation of what multiplication looks like in the opposite algebra with respect to this star. So what we have is f star, star, lots of stars here, G star x comma y. So what is this? This is sum over all z f star x comma z G star z comma y. But I can write that as sum over z going back into p f of z comma x g of y comma z. And so this is the same as summation g of y comma x f of y comma z, just using the commutation in C, z comma x. Okay, but that's nothing but g star f of y comma x, which is g star f star of x comma y. So what we have is f star star g star is equal to g star f star. In other words, this isomorphism star reverses the order of multiplication. So the multiplication in AP op is essentially the same as the multiplication in AP, except that the order is reversed when we identify the elements of AP op with the elements of AP using star. So this is called an anti-isomorphism sometimes. So it doesn't mean that AP and AP op are isomorphic. What it means is that these algebras are themselves opposite of each other in the sense of opposite algebra. And an immediate corollary of this is that we can compute the Mobius function of P op. Mu P op is equal to mu P star. This is not difficult to check. Let's just check. So what happens if we take mu P star and multiply it with zeta of P op? Now note that zeta of P op is nothing but zeta of P star. And so this becomes zeta of P star mu P star, which is delta of P star by the fact that mu P is the Mobius function of P. Okay, but delta of P star is just delta of P because this is anyway a symmetric function. It's non-zero if and only if x is equal to y. And so mu P star is the Mobius function of P op.